don't need particularly Altium Designer installed on their PC to see your work. Finally, when it comes to manufacturing, here also Altium 365 simplifies the process of working with the manufacturers as well. You can share the manufacturer data like the web files from the platform directly, ensuring smooth communication and reducing errors during production. In short, I'd like to say that Altium 365 transforms PCB design into a collaborative cloud-based platform where you can design, share, and manage your projects easily, no matter where your team is located. So it has created a workspace for myself called SMIT Workshop. So initially it will ask all the members in your organization to be invited to your workspace. So we don't want all of them to be invited to your workspace at once. So we'll skip this step for later. Like I said, it includes some sample projects that pre-included when you create a workspace. So these are the sample projects. So you can view them, or if you don't want them, you can delete them, and it will be stored in the trash section over here. So we'll come back to this Altium 365 later and how you can use this. I'll show you in further steps. So we've created a workspace here. So if you click on the workspace section, you won't see the workspace here that we created just now, because we need to relaunch the software in order to appear here. So we'll close this software and we'll relaunch the Altium Designer again. So each component has a unique footprint that matches with its size, shape, and pin configuration, ensuring proper electrical and mechanical connection is there. So we'll move all these components to the top section over here. So the same thing like we did in the schematic sheet, in order to zoom in and zoom out of the schematic sheet. You can press and hold control on your keyboard, and using your mouse scroll wheel, you can zoom in and zoom out of the schematic sheet. So we'll select all these components together by pressing and holding on the right mouse button and selecting all the components and moving them to the top section over here. So it's easier to do the placement. So initially, if you want to do the placement or do the layout, we need to draw the board outline. So PCBs come in various shapes and sizes. So for my requirement, a simple rectangle would be sufficient in order to place all these components. So to draw the board shape, we'll draw this on a mechanical layer. So in the bottom section here, you can see all the layers here. This is the top copper layer, this is the bottom copper layer, and these are all the mechanical layers. And we'll create a board outline layer specifically to draw. So these resistors are placed here, R3 and R7. So it decides the simplified diamond IC. And the rest of the components are the capacitors and this one header. We'll place one of the capacitor here and one more over here. And we'll place it the header towards the corner of the board. So it is always a good practice that any kind of connector you place in a PCB, it should ensure that it is placed towards the edge of the PCB. So now we're done with the placement. So now we don't require a schematic sheet anymore. So we'll merge these two together. So in order to do that, you can left click again on your tabs section over here and you can select merge all. So our placement is done. So I believe this area is going to be waste, so we can reduce the board even more further. So I'll only select the board outline here and press Shift S to highlight only the board outline area. So that is the shortcut key. So it will only highlight the board outline area and you can select the board outline. And you can bring this a little bit closer. And you can select the whole area and again go to design, board shape, define board shape and select objects. The rest of the area is clicked off and this is our final board shape. And you can press Shift S again on your keyboard to highlight all of the area. So before we start designing our PCB or make the connections of our PCB, we need to set a couple of rules. So these rules are typically set by the manufacturer. So these rules can be accessed by clicking on the design rules. And if you click on, there are various rules that you can set here. So I'll only explain the important ones. That is currently the units is set to currently mils. So I like to work in millimeters. So if you want to change the units to millimeters, close this and you can press Q on your keyboard. So at the bottom left corner over here, you can see the units. So it's currently set to mils. So if you press Q, here you can see it has changed to millimeters. So if you press Q, it will toggle between mils and millimeters. So again, you can go to design and rules. So these rules, there are various rules, like I said, like clearance rule, there is track width rule, and BR rule, and silk to silk clearance. So it is a critical part of the PCB design. So these rules depend on your project requirements, component specification, and like I said, manufacturing capabilities of your chosen PCB fabricator. So give a small detailed view of how to set these rules. So one rule you can set is the main rules are in electrical. Then click on clearance. So clearance rule is to avoid electrical shorts between conductive elements. Validate, and you can select execute changes. So you can close this dialog box. So you can see all of these parts here. So these are the footprints of those particular logic symbols that we have created in our schematic sheets. So these are all the footprints for those particular parts. So a footprint in PCB design refers to the like I said, a physical layout of the pads, or here you can see holes, and it is represented by an outline of the PCB that corresponds to the specific electronic component. So it acts as an interface between PCB and the component, ensuring that the component can be properly mounted or connected. So here you can see pads or copper areas, they call it as, where the component leads or terminals will be soldered. So, and it also has a visual boundary called silk screen outline for easy identification during the assembly process. And it also houses knots or other features for mounting or alignment. And it is also named as, you can see here the reference designators. So these are called as reference designators. So it is nothing but a label indicating the